Over determining shells and valence electrons. Now, remember we talked about the atomic theory and how our modern day atom has these orbits around them, or these shells. Okay, so these shells are the energy levels that the electrons are found on. Okay, I also briefly introduced valence electrons. We're going to go into a little bit more depth on what that is. All right, so first we introduced groups and periods. Now just to remember, this periodic table is color-coded, so periods are rows going across the periodic table. The elements in each period have the same number of shells. So when we talk about the number of orbits that go around the nucleus of an atom where the electrons are going to be found, this is where we can find it. So looking at this first row here, this first period, we're going to have one shell. The second row, we would have two shells, the third would 3, and etc. Now, columns are called groups. So each element in a group has the same number of electrons in their outer shell, or their outer energy level. These outer electrons are called valence electrons. So if you're found in group 1, so you're in column 1, you would have 1 electron in the outer shell, not total. If you're in group 2, you would have 2 electrons in the outer shell, and then etc. all the way to the noble gases, well, you would have 8 electrons, except for helium. Helium only has 2 electrons. So if you remember the periodic table, looking at the atomic number tells us the number of protons. So the number of protons equals the total number of electrons. Okay, so this valence electron, again, is not the total number of electrons that these elements have. It's just the electrons in the outermost shell. So the group number, if you notice on your periodic table, I do believe the one that I gave you has A groups. So you'll see in column 1 it says 1A, column 2 says 2A. And then if we go to column 13, that is 3A. And then 14 would be 4A. If it does not say that on your periodic table, please write this in. Column 1 is 1A, column 2 is 2A, column 13 is 3A, column 14 is 4A, column 5 is 5A, column 16 is 6A, column 17 is 7A, and column 18 is 8A. These A groups tells us how many valence electrons there are. Now the transition metals we kind of avoid for now. They have slightly different rules for shells, and you won't need to know that in this class. You'll talk about it if you take chemistry. All right, so let's look at the number of shells and valence electrons for the element carbon. So you need to get out your periodic table that you color-coded yesterday and look at how many total electrons carbon has, and we're going to look at the period and group as well. Okay, so first off, let's find carbon. Carbon is found in the second period, so you'll see that we have 2 shells in carbon. Carbon is found in the fourth group, so in the outer shell, that second shell, there's going to be 4 valence electrons. Okay, so you will see that carbon is element 6 on the periodic table, so it has 6 total electrons. So if you notice in the first shell we have 2, and in the second shell we have 4, so a total of
what are you talking
6.
about?
Sorry about that. Okay, let's look at the next element. The next element is sodium. Okay, sodium on the periodic table is element 11, has the symbol Na. You'll see that sodium is found in the third period, therefore there are 3 energy levels around the nucleus of sodium. Sodium is also found in the first column, or the first group, so that means that outer energy level, there's only going to be 1 electron, so 1 valence electron. However, we do have a total of, if you count them, 2 on the first, 8 on the second, that's 10 plus 1, 11. So the atomic number for sodium is 11. All right, so let's do one more together, and then I want you guys to try to finish the rest of the worksheet on your own. So we have neon. Find neon on the periodic table. Now, if you look on the back of your periodic table, I did put them in alphabetical order to help you a little bit easier to find them. Okay, so neon. Neon is in the second period, so that means it has 2 shells. It is found in the 8th group, therefore it has 8 valence electrons. So this is what neon would look like. We would have two shells, so two orbits outside of the nucleus. On the first orbit, we have 2, and on the second orbit, because it's found in the 8th group, it has 8 valence electrons. Now, it has a total of 10, because neon has an atomic number of 10, so that's 10 protons, 10 neutrons. However, 8 valence electrons, so 8 in the outside shell. All right, so I want you guys to try the rest of them on your own. So that concludes the podcast for valence electrons and